Please welcome to the stage Bill B.K. Kelley, Vice President and Air Force and Space Division Manager, ManTech. Tom Martin, Senior Director for National Security Programs, Blue Origin. George Prueger, General Manager of the Defense and Commercial Launch Systems, Aerojet Rocketdyne. Kiko Dontchev, Vice President, Launch, SpaceX. Colonel Brian Chatman, Commander, Space Launch Delta 45, United States Space Force, and Colonel James T. Horne III, Commander, Space Launch Delta 30, United States Space Force.
Good afternoon. All right. Sorry, I'm going to need those to see my notes. All right. So as he mentioned, my name is B.K. Kelley. I will be the moderator for this panel. The panel is called Launch Innovation and Throughput. And I'm joined by this esteemed panel of guests from both the military and industry. So today's panel is going to talk a little bit about where we're at currently with the launch tempo on both coasts. We're going to talk a little bit about what's happened over the last few years that's gotten us to this point, and then we're going to talk about what we need to do to be ready for the next 5 to 10 years. So a little bit about myself. I am the Vice President for Air Force and Space at ManTech. And when I graduated from college, as a young engineer, my first job was designing payload fairings for the Titan IV. So before you pull out your calculator watch to do the math, I'll do that for you. It's a little over 30 years ago that I got involved in launch. I am still involved in launch today. Still love being involved in launch. I'm excited to be here. So today I'm going to have each of the panelists introduce themselves and give them a little bit of background on what they're doing and their role in launch. So I'll start here to my left with Colonel Chatman. Over to you.
Hey, I'm Colonel Brian Chatman. I'm the Space Launch Delta 45 Commander. I've got Patrick Space Force Base, Cape Canaveral Space Force Station in the Ascension Island, and operating at a launch cadence that we just haven't seen.
Hey, Jim Horne, Space Launch Delta 30 Commander at Vandenberg, where we launch and then host a whole host of really critically important strategic partners like Space Forces Space, Combat Forces Command, STARCOM, MDA, Global Strike Command.
Tom Martin, Blue Origin. I am based out of LAX Terminals 2 and 3. My background is launch propulsion. It's only been in the last couple of years that I figured out they put stuff on the top of the rocket, and I love the rocket equation.
Ballast.
Kiko Dontchev. I'm the Vice President of Launch at SpaceX. I oversee all of the infrastructures, operations, and all the activities we do both at the Cape and in Vandenberg. I've been at the company for 16 years, so I like to tell people I'm the rare breed of millennial that's only worked one place their whole life.
I'm George Prueger, General Manager of Defense and Commercial Space Launch Systems at L3 Harris Aerojet Rocketdyne. My business area includes the RL-10 engine, which has a 60-year heritage of propulsing spacecraft to every planet in the solar system. My introduction to launch was as part of the R68 development team, and just love to watch those Delta IVs. Unfortunate not to see them anymore, so thank you.
Thanks, George. All right, let's get into some Q&A if we can. So the SecAF this morning talked a little bit about the increase in tempo. Colonel Chatman, you guys hit 100 launches this year already. And Colonel Horne, since 2020, you guys have increased your launch tempo by 1,300%. And that is not 13% or 130%, that's 1,300%. So with that, my question is, this is going to be a two-part question. The first part is, what's happened over the past couple of years that's making significant changes to the launch manifest, with specifics from your respective coasts?
Yes, so we were talking earlier, Colonel Chatman brought up a good point. Like, how many launches did you do in 2019? So our number was 9. 9 launches in 2019. That's what everyone was used to at Vandenberg. People are shocked this week as I catch up with folks that I've known for a long time, and they say, how are you guys doing? And I said, we're doing great. How are you launching? A lot. How much? 68. 68 launches this year so far. from Vandenberg. We expect to hit somewhere in the neighborhood of the mid-70s, 75 sounds like a good round number. 1,320% increase in the last 5 years. I think we will hit over 100 in the next couple of years, and we're posturing to support as many as 150 to 200 launches a year in the future. So just tremendous growth. We have two major strategic efforts that we're working to expand that. I think what's driving it is reusability and launch rate increases as we build out proliferated LEO architectures and things like that, and then leverage the commercial services on orbit as part of our commercial space strategy in the Space Force to leverage capability that we don't have to build ourselves and can buy on orbit. But we have two major efforts: Spaceport of the Future, infrastructure. We're investing $861 million into Vandenberg right now, upgrading our roads, harbors, our electrical grid, our gate capacity to handle the traffic coming through our gates, just to source the commodities for these rockets, to essentially overhaul and buy off a tech debt that we've incurred since the 1960s. And the whole goal of that entire effort is to unlock our capacity and continue to increase our launch rate. The second piece is what I call defend the mission, and that is to harden our infrastructure and prepare for a denied environment that we may have to fight through in upcoming conflicts. And so things like counter Suez, protection of our perimeter, cyber defense as we stand up a cyber defense squadron that we inherited from Combat Forces Command to defend our mission networks and all of those things.
2019, when we stood up the Space Force, I was out of Vandenberg and was always jealous of what the Cape was doing. In the 6 years ago timeframe, we launched about 20 times off the Eastern Range, and just before Thanksgiving, we broke 100 launches. That close partnership with the launch service providers and working with to identify what type of upgrades from a logistics and infrastructure perspective, from a commodities flow perspective that we need to account for today to be able to facilitate those launches and plan for tomorrow is a big focus area that we have out at the Cape and at Patrick. Colonel Horne talked about the infrastructure upgrades happening there at Vandenberg. We got just short of $1 billion in infrastructure upgrades happening too at the Cape. The largest facelift the Cape has seen in the last 2 decades is underway, and that's going to posture us not for the launch cadence that we see today, but what we see for the 2036 and beyond timeframe.
All right, thank you guys. So any other panelists specifically that want to kind of chime in on that?
I'll just comment on, like, we've talked about this huge increase, but like why the increase, right? So the first is the demand. The demand comes from the proliferation of large constellations in low Earth orbit. They're commercial from a communication perspective. Obviously, SpaceX has Starlink that's driven a large number of launches. But there's also a huge shift on the government side. When you look at the SDA missions, some of the other architecture that SpaceX is working on with large LEO constellations that can provide huge increases of capability and are definitely a shift from the traditional launch a bird, it's good for 15 years, right? Instead, we're building these huge constellations that have large number of satellites and you can replenish them quickly. So that's one. How do you serve that? You serve it through reusability. It's not just reusability of your orbital launch vehicle, it's your reusability of your launch pads, of your recovery systems, whatever it may be to enable that throughput. Actually in about an hour and a half, I think you may be able to see it from here. There's actually be a launch from Pad 40, which will be our 105th, I think, for the Cape, I believe. Can't keep the numbers totally straight in my head anymore. But that's following an NROL launch that happened on Tuesday. So a 49-hour turn on Pad 40 out of the Cape, right? That's an insane sort of launch cadence off the same pad. That sort of reusability is enabling hitting that demand. And then obviously, there's many new entrants now, right? We've got Blue Origin just had a huge success on their flight. We've introduced Vulcan this year. And so you've got many rockets entering the space, and it's just an incredibly exciting time in that sense.
Yeah. Kiko, that's awesome on the rate. On the RL-10 side, we're investing heavily in terms of our facilities. We're moving from 1 engine a month to one engine a week, which, getting back to SpaceX's, may not seem as much, but it's driving a lot of differences in terms of how we've configured that engine. We've driven new technologies into the manufacturing. We couldn't do it with what we call our tube-wall engine, so we're growing our chambers now and leveraging that technology. And then on the in-space side of our business, we're investing with commercial models because we're being asked to deliver propulsion systems much quicker than we typically have. And so how do we get ahead of that curve and be able to support the demand that's coming on a shorter timeline? So those are the things that we're doing.
Thank you, guys. It was a two-part question, but I think you guys all answered what are we doing about it, right, to address it. I would just add one comment. We talked about this as a group. There are some other factors in there, specifically these big LEO constellations, right, and the proliferated constellations that are going out there. Just the amount of payloads that have to be launched these days is kind of helping drive all of that. So I wanted to add that in there. Next question, George, I'm going to start this with you if you don't mind. Question is, how can Space Force more effectively leverage the speed and innovation of the commercial sector to meet the national security needs, particularly in the face of evolving threats?
Okay, first off, one of the things we're doing is leveraging more advanced manufacturing techniques. Like I mentioned, we're moving from the copper, or from our tube wall construction to additive manufacturing, because we can much quicker manufacture the chambers and move to an engine a week, or even more than that, from an engine a month. Then the other things that we've done is we have a co-located team down in our West Palm Beach facility. And that enables us to more quickly attack problems and provide the speed and get the innovation. We've got all the facilities there, so in an instance where we were working on our RL10CX engine, which is a development engine of our additive manufacturing engine, we got into a point where it was taking a long time to do analysis to close on a gap in the chamber. And so we just went and built a chamber and tested it like 100 times to show that it was adequate to meet the demand. So taking some of the SpaceX type approach, where you just go test it, build it, fail it, and redo it. And then we work very closely with our customers to align our technology roadmaps, make sure that we can stay ahead of it, align our technology development in line with that. To more directly answer that question, I think I'd also like to hit, there's a couple items that I see that help drive speed and innovation. One of them is getting the requirements down to only the requirement set that you need. One of the things on the RL10CX, we worked with Space Systems Command as we were doing that development. We designed that engine with 80 requirements versus our typical engine that we're flying right now has over 280 requirements on it. And so that opens up the space for the design teams to go work the scope that's needed. And then we also was very intentional in terms of how we flowed our requirements down to our supply base, because requirements drive cost and schedule, because every single one of them needs to be verified, so you either have to do tests or analysis on that. So if you minimize that, do your verifications at the right levels, you can increase speed of development to get the new systems on board. The other item I want to mention is doing good mission risk management, if you will. We have a number of systems. RL10, for one, has been around quite a few years, and it's been qualified to certain requirements. The missions are evolving, and as those missions evolve, you'll find that these systems may not be fully qualified to those requirements. Case in point, or the RL10B2, the last one on the planet, flew on Artemis 1 on the ICPS stage, and it had been acceptance tested 17 and a half years prior. But the mission hadn't even existed. But we went through with prudent mission risk management, and were able to execute that mission with the shortest first burn ever on an RL10 and the longest second burn ever on an RL10. So it's weighing those things so that you can reduce the timeline to put the systems in space that you need to.
Excellent, thank you. So from an industry perspective, any additional comments about what the Space Force can do?
The only thing I'll add is, I think it's important that, especially as we look in the future, you know, you guys, we got these dollars, right? We want to put the dollars to work. But it's critical we look at putting the dollars to work on really the things only the government can do, right? So there are places where there has been traditional government functions as it comes to how a range functions, how we do surveillance, how we do AFTS, obviously, that I think we've seen the commercial providers start to take over. So there is plenty of opportunity to leverage. Let the company do it itself, right? If they have the resources and the ability, and especially if they're an established player, let them work on those functions. Let's figure out a way to build the policy such that A user can provide their own commodities, can provide their own power if they need to. I would say power is probably one of those things where upgrading the base power is more of a holistic thing, but can be also done by the user. And then really drive the range function, the government function, to work on those things that truly only they can do.
I do think also from the adversary threat perspective, as we talk about launch resiliency, I think there's going to be more dialogue on what are those threats, and from an industry perspective, what do we need to be doing to protect our capabilities, whether it's the launch sites, the vehicles, and what innovation can we bring to helping negate those types of threats?
BK, I love that question. Next week, in partnership with KSC, we're going to host a Reversed Industry Day. We're bringing the industry launch service providers together to talk about where we have choke points in the throughput for today and where we anticipate choke points for tomorrow, what the government needs to be focused on, what we can partner with the launch service providers on, and what we can partner with the state of Florida on to get a holistic look across the Space Coast to really maximize efficiency and throughput and get mass to orbit.
And let me just finish by saying, I was reflecting as we were working through that question with the answers, where we've been, the journey. AFSS, like Kiko mentioned, was really the critical technology investment that industry made to really unlock our capacity. When you have to wait 3 to 4 days to flip the range from one rocket to reconfigure it for the next, you're by definition throttling your capacity. With AFSS, you no longer are as inextricably linked to the range infrastructure you need to do that. And so you can swing telemetry dishes and things like that for data if they need it. In some cases, they provision it themselves now. So the flight safety is on the rocket. That truly unlocked probably a doubling of our capacity just from that one thing alone. The other piece of this is processes. We don't have the luxury that we had in the past to wait to ensure we have quadruple redundancy. A lot of that was launch on time risk, not mission assurance risk. So we'll take the risk that maybe there's a delay in the op, but maybe not quite the capacity that we brought to bear from a spaceport services perspective to get it on the pad and get it out of there. So we're constantly now challenging every process and every decision we make. Why do we do it that way? Because we could. Okay, then let's change it. Let's change our assumptions and then change our processes and get quicker. And that's how you're seeing what we're doing today unfold.
That's great. Good to hear the differing opinions, right, between military and industry. Thank you, guys. Next question, Kiko, I'm going to start this one with you. Question is, with over 170 launches this year, and I don't know if we're going to hit 180 or not, but over 170 launches this year from the two ranges, infrastructure is strained, right? So we've touched on this a little bit, but the question is, what are the most urgent infrastructure changes or upgrades needed at Space Force bases to support an even higher launch cadence?
So we only hit 160 so far, so I don't want to count my chickens before they're totally hatched. But I think we'll get 167 this year, which is, once again, pretty amazing. But I used AI to come up with this answer, so don't quote me on it. Atlanta Hartsfield Airport did over 800,000 takeoff and landings last year, okay? So while 167, 105, getting 75 from each of the ranges sounds crazy to us, it's nowhere close to how an airport operates. So if we are going to really take the next leap, we need to think about spaceport like aircraft-like operations, where our spaceports support multiple launches a day from multiple providers. They're not necessarily, maybe one flies more than the other, but there's equal footing, and the ability for everyone to fly is always there. That's going to come down to three main elements. The first is obviously infrastructure. We like to call it throughput. And the reason we say throughput, it's not just roads, it's waterways. It's all of the functions to be able to move the hardware and the people that make it possible to have such a launch cadence. We need to invest in a lot of science on blast and acoustics. I mean, one of the biggest pieces of feedback we hear about our large vehicle, and especially coming to the Cape, is how loud is Starship going to be? How is it going to impact the rest of the operators? We believe we've done some pretty good science, and it's not going to be maybe as impactful as some of the media outlets report, but that science needs to continue. And then third, and really a very important part of this, is we need to invest in the tools to manage the airspace, right? And to manage the scheduling of how you do all these things. These have been traditionally very manual type operations. We need to become much more operating in the way we move our vehicles, the way we schedule our vehicles, and then the way we manage our airspace. I mean, we really have to rethink the airspace problem because the traditional method is just not going to fly, and we're going to need to have much more concurrent operations with aircraft rather than having a static hazard area that gets shut down sort of traditionally. I just don't think it will work otherwise.
Thank you. So Tom, I'm interested, right? 2 different companies, 2 different vehicles, 2 different sets of processes and logistics. Anything additional that you see from an infrastructure perspective?
No, I think we're trying to solve the same problem, which is how do we make space access more routine by launching more often. So I think we all see the same thing. I think everybody on this panel is trying to row in the same direction. Is what do we need to do from a policy perspective, from a regulatory perspective, from the physical infrastructure to enable, that aircraft-like operation. I will say a rocket is not quite an airplane, so we're probably not going to be doing 800,000 flights. And also, I spent a lot of time in Atlanta, stuck there. But, so no, we're all rowing
see
in
a
the same
theme, by the
direction,
way.
for sure.
There's a theme to your airport travel.
Let me just add one more thing on the policy. And this is something Colonel Horne and Colonel Chatman and I have talked about. We want the commercial providers to pitch in and to help contribute greatly to the funding behind what it's going to take, but we have to do it in a time-relevant fashion. It's not helpful if it's going to take 10, 15 years to build a road, right? We need to be able to do things on the days to months scale, not on the years to tens of years scale. So we need the policy to reflect letting commercial industries loose on getting those infrastructure projects done.
Thanks. So Colonel Chatman, Colonel Horne, I know you guys have some thoughts around infrastructure, right? Anything to add about what should or could be done?
Yeah, under the Spaceport of the Future infrastructure money that we got, the millions of dollars that we're doing in infrastructure upgrades, that was based on throughput and manifests that we saw or thought 2 years ago. We've seen the launch cadence change, we've seen the launch vehicles change, and now we're taking a look at, while the initial plus up in dollars was great to help get work areas out of hazard areas and deconflict operations to maximize efficiency, move personnel out of the industrial area at the Cape so launch service providers continue to bring in launch-related hardware, put things together to move out to the launch pad and get that launch on. This reverse industry area we're doing next week is to talk about what's needed for tomorrow. As we have more and more launch happening, do we need a booster transport lane at the Cape? So as boosters are recovered on barges and need to be transported back to the launch sites, it doesn't impede the flow of traffic of folks I have coming and going to work every day there. How do I get commodities, hundreds of trucks worth of commodities over to each of the launch sites for what the LSPs need to be able to launch tomorrow's capability and get that mass up on orbit? Or do we need a pipeline? What does that look like? That holistic look end-to-end is what we're discussing now for the launch cadence in 2036, where we anticipate over 300 launches in a calendar year happening off the Eastern Range alone, much less the increase we're going to see out of Vandenberg.
Yeah, it's going to look a lot like LAX in the future, and that's what we're posturing for. Sorry, I picked the West Coast airport. On the West Coast side, we're investing $500 million in our wharf. Right now, we have launch providers that literally hire surfers to help them surf into the port to dock, to offload their rocket, because we don't have the adequate seawall and things like that to control the tides and make it like a normal port. So we have to invest the money to make that a port that can truly operate simultaneously. We operate out of that wharf about 50% of the year. We're trying to unlock that to almost 100% if we can. Dual operations, where 2 providers can come in at the same time, offload their rockets, move on for the next one. So that's one example. I think I concur with the policy piece of this. We can only move as fast as the processes allow us to. We are limited in our ability to partner with industry, to partner private money with public money, to work together on military construction projects and things like that. There's a certain process we have to follow right now that restricts our ability to move fast. And so those are some of the things we need to work on there. Flexibility in how we partner money, like I mentioned before. So I think we continue to innovate. It's incredible what our folks are doing on a daily basis. We used to take 2 years, sometimes 4 years to onboard a customer to the range. We can do that now in months. We actually built a digital twin of the spaceport. People talk about digital twins. We're using one. And it's telling us you need to invest here, here, and here. These are your critical choke points. This is where you unlock the next tranche of capacity that you need to truly get to the demand signal that you're receiving. And so we're exercising all of that and investing our money intelligently where we can to truly unlock our capacity.
Thank you. All right, I'm going to switch gears here a little bit. We've talked about some technology and innovation. We've touched on additive manufacturing and propulsion and even reusability and AFSTS. This question is a little bit more geared to looking into that 5 to 10 year time frame that we talked about. What emerging technologies in ISAM, right? So servicing, on-orbit servicing, assembly, manufacturing, or even some of these other technologies that we've talked about hold the most potential to fundamentally transform space access. I'm going to start with you, Tom, on this one.
Yeah, thank you. So I think this one's kind of a chicken and the egg question, and I think it's worthwhile to really start on what do we want from a logistics perspective, from a space access perspective in 5 to 10 years, and then we can answer the question, what technologies do we need to support that? I think on the space access side, we obviously have a desire for more launch in general, but we want to reduce cost. We want it to be more responsive, especially from a military perspective. We want it to be more resilient. On the logistics side, we really need to talk about what missions do we want to be doing in 5 to 10 years that potentially need to be supported by logistics and logistics-associated technologies. I think the good news is on the space access side, the technologies we could apply to responsiveness, resiliency, cost, they all go together. The more often we launch, the more we have to figure out how to be resilient to anything that could go wrong. And that's going to kind of drive us to, I think, that future where we are more responsive, we are more resilient, we can swap out payloads quickly because one provider didn't show up. I think that's just kind of going to happen. I do think there's some military-specific use cases of responsive launch that will be coming forward that I think will be interesting to see how we work those between commercial capabilities and what the government needs specifically. On the logistics side, I think there's still more questions as to what exactly do we need out of a logistics chain. And I think one of the good things is all the logistics get better if space access is more routine and cheaper. But beyond that, I really think we need to look at what do we need to be doing in space that needs to be supported. Is it, concepts of dynamic space operations? What do those operations actually represent? What do they mean? Sustained space maneuver terms we hear a lot. On the civil side, the exploration side, what does a logistics chain to the lunar surface look like, and what does it need from logistics support? So I tend to really focus on, let's answer those questions before we dive really into the technologies. But I do have to specifically talk about refueling, because I know that's kind of been when people talk about logistics, we go to refueling. And I'm a little bit concerned that, one, we haven't answered the question, why do we need to refuel? And I'm also a little concerned that it maybe is going to create bad behavior. We're coming from a place where we had high-value assets that sat on orbit for 10 to 15 years, and that drove all the things that we're trying to back out of. And if we talk about refueling things, then we think, oh, they need to last longer. And maybe we're getting away from the idea of, hey, if we're launching all the time, we can launch things that don't need to last as long. We can do tech refresh. We can get new capability in faster. And maybe that's better, especially now in the next 5 to 10 years, than at figuring out how we go refuel something. So I think that's an important point. And so what I'd really advocate is not to talk specific technology that we need. I think we need to spend more time experimenting with a lot of different technologies, because as we learn what dynamic space operations really represents, as we figure out what that lunar permanence model looks like, we might not know the exact technology we need. So we need to be trying all of it, is my point here, and not just pick the technology today that we think we need.
Thanks. George? Kiko, sorry, Either of you.
I was just going to address that, from a propulsion system perspective, we're looking at these missions that Tom was talking about and working with the customers and looking at providing all sorts of propulsion that is in our heritage, but also in the development. Like we've got electric propulsion systems that are out there. We've got nuclear thermal propulsion, nuclear electric propulsion that we're developing. And we're also developing systems recently tested in terms of very low Earth orbit type hybrid systems to be able to leverage that type of orbit to support the mission also.
The only thing I'm going to add is the fundamental technology that needs to get built is true and rapid reusability of our orbital vehicles. We do that, the cost of access to space drops by an order of magnitude again, and the opportunities increase by an order of magnitude, and we beat China. We need a fully and rapidly reusable, we need multiple fully and rapidly reusable launch vehicles. That's how we get to the finish line. You do that, everything's on the table, but without that, we're going to struggle getting to the next step.
Great. Gentlemen, any comments from the government side about any of the technologies? I know ATS has been looking at SML and that, so I'm just curious from a government perspective if there's something.
Yeah, I don't think refueling is about making it last longer. I think it's about driving your Corvette like a Corvette. I think that's what you're trying to do. If every time our operators have to worry about how much fuel they have on the satellite, they have to think very hard about which operation they choose to make with it to expend the life of the system. So if we can unlock the life of the satellite from the fuel on board, you've changed that equation from a maneuver perspective. And so I don't disagree with you. I think as the cost of launch has gone down, the cost of satellite technologies has gone down, we can rapidly reconstitute and almost do like a rinse, recycle, repeat kind of construct. But in terms of maneuver on orbit, I mean that's why the Space Force exists largely, is to defend those assets on orbit. You can't do that if you can't maneuver. From a logistics perspective, launch is logistics. Transport is one of the key functions of a logistics chain, but everyone says it, logistics win wars, and I think as we continue to push the envelope and innovate in the logistics realm, we're increasing our ability to, for strategic advantage against our adversaries. Things like competitive endurance and the theories of success that you've heard the Space Force, the CSO push, that's what unlocks those capabilities, and we just need to continue to innovate and push to win.
All right.
We have some extremely smart guardians getting after requirements and acquisition programs, and when they're ready, they're going to bring them to the range, and we're going to be ready to launch. It's going to be awesome.
It is going to be awesome. All right, that's a good transition. Colonel Chatman, I've got you teed up for this next question here. You showed some passion about this topic when we were talking earlier. The question is, how can the Space Force and industry work together to create a more dynamic and flexible launch manifest across NSSL, national launch, and civil? Right, so not just Space Force centric.
Yeah, the dynamic range scheduling operations has been huge to work manifest options and opportunities across to be able to get satellites on orbit when they come off the production line and are ready for launch. We used to talk national, commercial, and civil capability, but really it's NSSL, it's national, non-NSSL launch, and civil that we're launching from the eastern and western range. It's capabilities that we're getting up on orbit that we are buying services from a commercial lens that we're using for military utility purposes. It's our national security space launch assets going up in that partnership with NASA on that civil front that all comes into a dynamic scheduling model that allows us to maximize efficiency from range operations to really increase throughput of getting mass on orbit.
Yeah, I agree. We need a new vocabulary, right? When people say, well, that's a commercial launch, what they tend to mean, although it can mean many different things depending on the person speaking, is that's not a national security priority launch. That's no longer the case. That's the opposite of our strategy, which is to maximize capability in orbit from both industry as well as those things that only the military can do or that only satisfy military requirements and there's no commercial market for, right? So launch is just launch. What's on top will unlock based on whatever acquisition strategy we have to access that capability or those services. So when we talk about commercial launch, really what we're talking about is commercially licensed launches versus launches that we indemnify ourselves from a mission assurance perspective. But we're leveraging all that capability, which is exactly what we said we would do in our commercial space strategy.
Excellent. From an industry perspective, any thoughts from our panelists at that end about, I mean, most of you are launching across all of these areas,
I mean,
right?
the only thing I'll say is national security launch is always going to be our highest priority, along with, you know, serving the human space flight. We've got commitments with the government, SpaceX does, and we've realized the importance and the criticality of those missions. So we've tried to put as much precision as possible into ensuring that when the need is there, we're ready to serve, we're ready to hit it on time, and most importantly of all, is always going to be reliable, right? 100% mission success. I think for us, we try to build a manifest like a bus leaving the bus station every 2 days, right? And then we fit around that. And, you know, by having a fleet, by having reusability on Falcon right now, we're able to offer the government a lot of flexibility. So if something happens with certain hardware, if something happens with a certain pad, we've got the ability to quickly pivot and accomplish that, right? And still hit the mission. You know, not even on schedule, even earlier, maybe than you might need it. So you got to think about it. You know, I hate to bring up the airport analogy again, but if it's like there's an airplane taking off every hour, how do we get on that airplane, right? And how do we build payloads and missions that can be as flexible as possible, such that we take advantage of the capability that's really already there, rather than making it some bespoke thing that's harder to be flexible around.
Yeah, I'd agree with that. The idea that as long as we are launching very routinely, what goes up on top should be able to be swapped out very rapidly. And we will always give the government priority if they have an urgent need to put something on top of the rocket. They've got it, and how do we just make that timeline as short as possible when there's really an urgent need?
All right.
For us, really, regardless of what's on top of the rocket, it's absolutely important that it gets to where it needs to go for the mission. And so, but from the addition of the commercial and the NSSL and the NASA launches helps us with our consistent product line. So I get the volumes up and I get the costs down and support the timelines also.
Thanks, George. All right, so we're starting to wind down on time, but I do have one bonus question. So I'm going to take one answer from our Space Force folks and one answer from industry. The question is about government acquisition, right? And it's, are there any significant bottlenecks or things that are currently hindering all the stuff that we're talking about, that integration of cutting edge technology? So I'll start at either one of you on the Space Force side want to talk about?
I don't know that this government acquisition, I think we brought it up earlier, but it's the processes that we're held to when it comes to infrastructure projects and how quickly we can move with environmental assessments, with the construction itself, who we can contract with, the kinds of authorities we have for funding, flexibility, and things like that, and how we apply that to truly unlock capacity. We're working in close partnership with our providers to rebalance that cost share between the government and industry, and I think we're doing it in a responsible way that maintains our industrial capacity while still continuing to refine our authorities and be more flexible with how we invest. And so really it's more the policy things that I think that you're going to see us continuing to partner with the appropriate folks to chip away at.
But we're also seeing those discussions play out at the senior leadership across the Pentagon to give us and allow us that flexibility at a level that I have never seen before, right? This leadership team coming together to help get the launch ranges healthy and in the right spot is absolutely hands down amazing.
All right, thanks.
I do think there's an opportunity, not necessarily acquisition exactly, but in the certification side of being a little more flexible in the way we approach certification is not a static thing, but as the providers evolve their capabilities, evolve the technology that they're bringing to the rockets, that certification process is also a little bit more adaptable to onboarding those capabilities.
Anything additional?
I don't think of anything specific on acquisition, but because we're at the end of the time, I do just want to take a second to thank these two individuals at the end. We've had an absolutely outstanding year, and it wouldn't have been done without the partnership. I text these guys probably much more than they want to hear from me, and then they push back on me. But I tell you what,
Kiko, you got a head nod.
I think we won this year, and I just want to say thank you, and to all the men and women that are out there that serve this country. We very much appreciate your support.
Great. Well, we're winding down here, and that's a great segue to my thank yous. I want to thank each of the panelists for taking time out of their day, both industry and government. to make this panel happen. Thank you to the Space Force Association for putting this panel together. Thank you for the audience for sitting in and listening to what we have to say. Happy holidays to everybody, and we're done. Appreciate it.